Hello, good morning everyone. Today I would like to share with you a new topic based on system of first order linear differential equations. In this topic, you will learn how to solve the homogeneous system of first order linear differential equation through the finding of the eigenvalues and its corresponding eigenvectors. Apart from that, you also learn how to solve the non-homogeneous system of first order linear differential equations by using method of undetermined coefficients and also variation of parameters. System of first order linear differential equation can be written in this form. If y1, y2 and yn is linear, then we can say that it's a linear system and it can be written in this form. y1 prime equal to a1 1y1 plus a1 2y2 plus blah 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 a1 n yn plus g1 x. So same to y2 prime to yn prime. So if the equation is in a vector form, we can write in this way. So y prime equal to ay plus g. Okay. So from the equation just now, from the equation 2, we write in this form a1 1 a1 a2 1 a1 n. So this is the metric form. Y also in a metric, y equal to y1 y2 until yn, same to g1 g2 until gn. So this system is called homogeneous if the value of g is equal to 0. So that is y prime equal to a y. Okay, if g is not same to 0, that is called as non-homogeneous. So non-homogeneous means that the g has some value, either it's an exponent, trigonometry, or the constant. Now let's look at the example 3.1. Given that a system consists of two first order linear differential equation, y1 prime equal to 3y1 plus 3y2 plus 8 and y2 prime equal to y1 plus 5y2 plus 4 exponent 3x. They show that y1x equal to 3 exponent 2x plus exponent 6x minus 4 exponent 3x minus 10 over 3 and y2x equal to negative exponent 2x plus exponent 6x plus 2 over 3 is the solution of the system. So in this question, we need to show that this y1 and y2 is the solution for the y1 prime and y2 prime. So to do this, the first step is we write down the y1 and find the y1 prime. So y1 is equal to 3 exponent this one. We copy down this one. So 3 exponent 2x plus exponent 6x minus 4 exponent 3x minus 10 over 3. So we differentiate the y1x, we get y1 prime. Okay, y1 prime. So y1 prime equal to, we differentiate y1, we get 6 exponent 2x plus 6 exponent 6x, then minus 12, 3 times 4, 12, 12 exponent 3x. Then we get the y2x. So y2x is from the question. Okay, this one we get the y2x. So y2x is negative exponent 2x plus exponent 6x plus 2 over 3. So y2 prime equal to negative 2 exponent 2x plus 6 exponent 6x. Okay, this is a step 1. Then step 2, we need to substitute the value of, okay, we use this equation. Y1 prime equal to 3y1 plus 3y2 plus 8. So we substitute the value of y1 and substitute the value of y2, whether you will get the same value as you calculate here. Okay, so y1 prime equal to 3y1 plus 3y2 plus 8. So y1, just now you calculate, just as from the equation, is 3 exponent 2x plus exponent 6x minus 4 exponent 3x minus 10 over 3, then plus with 3y2. y2 is a negative exponent 2x plus exponent 6x plus 2 over 3, then plus with 8. Now you can simplify. You multiply in, you get 9 exponent 2x plus 3 exponent 6x minus 12 exponent 3x minus 10. Then minus, so this one times this one, so minus 3. So minus 3 exponent 2x. Then plus with 3 exponent 6x plus with 2 plus with 8. Okay, so you can simplify. Exponent 2x, so you have 9 exponent 2x minus with 3, so you get 6 exponent 2x, and then you have 3 and 3, so you plus 6 exponent 6x, then minus 12 exponent 3x. So minus 10 plus 10, you can cancel out. So this y1 prime, you get the answer like this. Then you check whether you get the same answer like this or not. So from the step 1, you get 6 exponent 2x plus 6 and then minus 12. So from the step 2, you get 6 minus 12 also. So this means that the answer are the same, right? The answer are the same. So this means shown. This means is the y1 is the solution for the y1 prime. Now we check for the y2 prime. y2 prime is y1 plus 5y2 plus 4 exponent 3x. So y1 we substitute with 3 exponent 2x plus exponent 6x minus 4 exponent 3x minus 10 over 3, okay, then plus with 5y2. y2 is minus exponent 2x plus exponent 6x plus 2 over 3, and then plus 4 exponent 3x. So you can multiply in this one. So I multiply in first. So exponent 6x minus 4 exponent 3x minus 10 over 3 minus 5 exponent 2x plus 5 exponent 6x plus 10 over 3. Okay, then plus 4 exponent 3x. Now you can simplify this one and this one, so you get negative 2 exponent 2x. So this one plus this one, you get 6 exponent 6x. And then this one can cancel out. This one minus 4 plus 4 also cancel out. So whether it is same or not. Okay, you check y2 prime, you will get negative 2 exponent 2x plus 6 exponent 6x. So same as the given question or not? Yes, negative 2 exponent 2x plus 6 exponent 6x. So it's the same. So when it's same, it's shown, means that the y2 prime, the y2 in the question is the solution for the y2 prime. Okay, are you understand now? As I told you just now, system of first order linear differential equations has two types, homogeneous and non-homogeneous. So in this topic, we will learn to solve the system of first order linear differential equation. We write the system into a metric form, then find the eigenvalues and its corresponding eigenvectors. And here is the procedure of the to solve the homogeneous system of first order linear differential equation. So first of all, we write in the form of y prime equal to ay. Then step 2 is find the eigenvalues lambda 1 and lambda 2. Okay, and the corresponding eigenvector. So lambda 1 and lambda 2 you can solve using calculator. Okay, or you can factorize it. After find the lambda 1 and lambda 2, you find the eigenvector of this. Then step 3 is to check whether the corresponding eigenvector is linearly independent or not. Okay, then write the general solution. So this is the general solution that you need to follow. Okay, this is the format of the general solution. Then if the question is given the initial condition, so you can find the particular solution for this. Now we straight away go to the example 3.2 to see how to solve the system of first order linear differential equation if the y1 prime equal to 4y1 plus 2y2 and y2 prime equal to 3y1 plus 3y2. So in order to solve this question, we can strictly follow to the procedure given as I mentioned to you just now. So the step 1 is to write in the metric form of y prime equal to ay. So we can write in the form of a metric. Okay, we transfer these two differential equations into a metric form. Okay, y prime is referred to the y1 prime, y2 prime from this equation. And then a is referred to the value. Okay, value for the y1, y2, and y1 and y2 for this one. So we can write as 4, 2, 3, 3. Then y1, y2. Do you know why we can write in this form? Because if we say that 4 with time, okay, metric, you time with this one, time with this one, so we're equivalent to 4y1 plus 2y2, which is same to this one. And similarly for the second row, 3y1 plus 3y2. Okay. We also can write in the form of just y prime equal to 4, 2, 3, 3, y. This is the metric of 2 times 2, in which the A is equal to 4, 2, 3, and 3. Okay, it's 2 times 2. So for the second step, you need to find the eigenvalue of the corresponding eigenvector of A. So what we should do is 4 based on the metric A, so only these two will have the minus lambda. Okay, so 4 minus lambda, 2, 3, 3 minus lambda. Okay, remember, only this line. Only this value will have to minus with lambda. Other remain the same. So 4 minus lambda multiplied with 3 minus lambda. Then minus with 2 times 3, so equal to 0. So this one, 4 times 3 you get 12, 4 times lambda you get minus 4 lambda, and then minus lambda times 3 you get minus 3 lambda, minus lambda times minus lambda you get plus lambda squared. Okay, and then minus with 6 equal to 0. So now I get lambda squared minus 7 lambda plus 12 equal to 0. So you can factorize it. Okay, I can have a lambda and lambda, 6 and 1 minus. Okay, so I factorize it. I get lambda equal to 6 and lambda equal to 1. So this is my eigenvalue. Then what about the eigenvector? So I need to substitute this lambda equal to 6 and lambda equal to 1 into the equation, into the metric form here. Okay, and get the eigenvector. So now for lambda equal to 6, I substitute the value of lambda into the metric. This is follow the step 2. Okay, so now I have to substitute the value of lambda, which is equal to 6. So after I substitute, then I can multiply this one, multiply with this one. So I have a negative 2. So 4 minus 6, you get negative 2. Multiply with the x, I get negative 2x plus 2y equal to 0. And same to the second row, that is 3 times x, okay, minus with 3 times y, so 3y equal to 0. Then we assume the x equal to s. So I get negative 2s plus 2y equal to 0 and y equal to 2s divided by 2, which is equal to s. So this means the y is equal to s. So my eigenvector equal to x, y also equal to, my x is 1, y also 1s. Okay, this is for the lambda equal to 6. So now I do for lambda equal to 1. Okay, similarly, I substitute the lambda equal to 1 here into the metric of this one. So 4 minus 1, 2, and 3, 3 minus 1. Okay, so 4 minus 1, you get 3. So 3 times x, you get 3x, plus 2 times y, you get 2y. So similarly to the second row, you have 3x plus 2y equal to 0, and assume the x is equal to s. Now 3s plus 2y equal to 0, y equal to negative 3s over 2. I get y equal to negative 3 over 2s, and the eigenvector equal to the x and the y. So the x is 1 and the y is negative 3 over 2s. Okay? And the third step. The third step is to check whether the eigenvectors is linearly independent or not. So we write in the form of lambda 1, 1, lambda 1, 2, which is from the eigenvector 1. And sorry, not lambda, is a eigenvector 1, 1, eigenvector 1, 2 from the eigenvector 1, and eigenvector 2, 1 and eigenvector 2, 2 from the eigenvector 2. So step 3, we check the linearly independent or not. So you have 1, 1 and 1 negative 3 over 2. So you will multiply this one and minus this one. So equivalent to 1 times with negative 3 over 2 minus with 1 multiply with 1. So this is negative 3 over 2 minus 1, which is equal to negative 5 over 2, which is not equal to 0. This means that this is linearly independent. So the last step, which is step 4 to find the general solution. So yx equal to C1. Okay, eigenvector 1, 1 and 1, 2, you get 1 and 1. This one, 1 and 1. Okay, 1 and 1 for the lambda equal to 6, right? So you have exponent 6 lambda. So this 6 is for the lambda 6 and the eigenvector is 1, 1. And then plus with C2, eigenvector 2 is 1, negative 3 over 2. And then for the lambda equal to 1, so you get 1x. So the first step is the general solution. Just now I refer to this general solution. Okay, this formula. So this general solution yx also can be written in the form of y1 equal to c1 exponent 6x plus c2 exponent x, and y2 equal to c1 exponent 6x minus 3 over 2 c2 exponent x. Okay, that's all for this question. Previous example showed that the eigenvector is a linearly independent. So we can write the homogeneous system in the form of linear combination. So this is the formula. But what if the eigenvector is not linearly independent? And usually for the problem with the same and repeated eigenvalue, means the same lambda, some value of lambda, we will have the not linearly independent eigenvector. This is the procedure for the eigenvector not linearly independent. Okay, if we have tested that the eigenvector is not linearly independent, first of all, we need to let the eigenvector 1 equal to E1, and then eigenvector 1, 1, eigenvector 1, 2 is the first solution. So we follow all the steps here to find if the eigenvector is not linearly independent. Now let's look at the example 3.3. Find the particular solution of the system of first order linear differential equation as below and consider its initial condition. So this question has the initial condition. Then we need to find the C1 and C2 value. So first of all, this first order differential equation given as y1 prime equal to y1 plus 3y2, y2 prime equal to negative 3y1 plus 7y2. By following the first step is we need to write in the form of y prime equal to ay. So a from the question is 1, 3, negative 3, and 7y. And then step 2 is to find the eigenvalue and its eigenvector. So first of all, we need to use this matrix A. Okay, only this value will minus with lambda. So 1 minus lambda, negative 3, 3, and 7 minus lambda. So 1 minus lambda multiply with 7 minus lambda. Okay. And then minus with 3 times negative 3 equal to 0. So you multiply in, you get 7 minus 7 minus lambda minus 7 lambda plus lambda square, and then plus 9 equal to 0. So you simplify, you get minus lambda minus 8 lambda plus 16 equal to 0. When you factorize it, you get lambda minus 4 square. Okay, so this means lambda equal to 4 and another value also lambda equal to 4. So now we got to find the eigenvector for lambda equal to 4. So we substitute the value of lambda. So 1 minus 4, 3, negative 3, 7 minus 4. Okay. So now you have 1 minus 4, you get negative 3. Negative 3 multiplied with x, you get negative 3x. And then plus with 3 times y, so you get plus 3y equal to 0. Same to the second row, so negative 3 multiplied with x, negative 3x, plus with 4 minus 3, 7 minus 4, you get 3, so 3y, plus with 3y equal to 0. Then we assume that the x is equal to s. So negative 3s plus 3y equals 0, y equal to 3s divided by 3, that is equivalent to s. Now you get the y equal to s and the eigenvector equal to 1 and 1s. And similarly to the second eigenvector, so second eigenvector also 1 and 1. Okay, the third step, okay, is to check whether the eigenvector is linearly independent or not. So the third step, you have 1, 1 and 1, 1 equal to 0, and then 1 times with 1 minus with 1 minus 1 times 1, so you get 0. So this is means that not linearly independent. When not linearly independent, you would need to follow this step. So you assume first the eigenvector 1 is equal to E1 equal to eigenvector 1, 1 and 1, 2. So you assume so this 1, 1 is from the top. This one is from there. Okay? This means this one is from here. So we assume this one is the first solution. And then B, we assume the A minus lambda I E2 equal to E1. Then you need to find the E2. That is the procedure that written in step 3.2. Okay, find E2. So now you assume E2 equal to A and B. So now assume that the A minus lambda I. So A from the question is 1, 3, minus 3 and 7. A minus lambda you'll get is, what is the lambda? Lambda is 4. Okay, lambda is 4. So minus with 4 I. I is referred to the identity. So 1, 0, 0, 1. Okay, then you multiply with the E2. E2 is A and B. Equal to E1. Equal to E1. E1 is 1 and 1. Okay. So this is A minus with lambda I. E2 equal to E1. Okay. So you substitute, not to substitute, we can say that is you solve the equation of this part. So 1 minus 4, okay, so you have 1 minus 4, and then this one, 3 minus 0, you get 3, and then minus 3 minus 0, you get minus 3 also, and then 7 minus 4, you get 3 also. Then have the A and B equal to 1 and 1. So you multiply in negative 3 times with A plus with 3 times B. Okay, so negative 3A plus 3B equal to 1, and then negative 3A plus 3B equal to 1 also. Then we assume A is equal to S. Okay, so negative 3S plus 3B equal to 1. So B equal to 1 plus 3S over 3. So B equal to 1 plus 3S over 3. Then we assume again the S equal to 1. Okay, we assume the S is equal to 1. So eigenvector would be 1. And then this one is 1. So 1 times 3 you get 4. 1 plus 3 you get 4. So 4 over 3. That is the eigenvector. Next is the second solution. Eigenvector 2 equal to E1x plus E2. So eigenvector 2 equal to E1 is 1, 1. You assume is 1, 1. Plus E2 is the answer that you obtained just now. So we can also write in the form of x plus 1 and x plus 4 over 3 for the eigenvector 2. And then step 4 is the general solution. So yx equal to C1 eigenvector 1. So I straight away write down the eigenvector 1 is 1, 1. For the lambda of 4, so exponent 4x plus with C2. Say C2 is x plus 1. This is referred to here, x plus 1, x plus 4 over 3. For the lambda 4x also. Also, I can write in the form of y1 equal to C1 exponent 4x plus C2 x plus 1 exponent 4x. And y2 equal to C1 exponent 4x plus C2 x plus 4 over 3 exponent 4x. The given question with the initial condition is y0 equal to 0 and 4 over 3. So we substitute the initial condition in the particular solution. So when x equal to 0, y1 equal to 0 also. So 0, so we can use this. Okay, we substitute in the y1. So y1 equal to 0 equal to c1 exponent 0 plus c2 0 plus 1 exponent 0. And then for y2 you get 4 over 3. So use 4 over 3 equal to C1 exponent 0 plus C2 0 plus 4 over 3 exponent 0. So now C1 plus 4 over 3 C2. So I assume this, okay, C1. Now this is 1, this is 1 also. So this one is 0 equal to C1 plus C2. This means C1 equal to negative C2. So this one I assume is equation 1, and this one I assume is equation 2. So I must substitute the equation 1 into equation 2. So I have 4 over 3 equal to C1 minus C2, minus C2 plus 4 over 3 C2. So 1 over 3. So you solve this one, you get 3 equal to 4 over 3. So C2 equal to 4. And C1 equal to negative C2, which is equal to negative 4. So Y1 equal to negative 4 exponent 4x plus 4x plus 1 exponent 4x. This is equivalent to 4x exponent 4x. For Y2, you can just substitute the value of the C1 equal to negative 4 and C2 equal to 4. Okay, I substitute in. Okay. So again, I can simplify it. So negative 4 exponent 4x plus with 16 over 3 exponent 4x, I get 4x over 3 exponent 4x. So I have 4. For this one, I have the x plus 1 over 3 exponent 4x. Okay, that's it for the Y1 and Y2. Lastly, I would like to share with you an example in which the lambda or the eigenvalue is in the complex number. So now let's look at the example here. Solve the following of the first order linear differential equation. So first of all, we write in the form of y prime equal to ay. So a from this question is negative 1, 1, negative 1, negative 1, okay, and 1. Then you find the eigenvalue. So eigenvalue, you get the minus 1 minus lambda, 1, negative 1, negative 1, negative lambda. Okay, so your negative 1 minus lambda multiply with negative 1 minus lambda. Minus with 1 times with negative 1 equal to 0. So you get 1 plus lambda, okay, 1 plus lambda plus lambda plus lambda squared plus 1 equal to 0. So you get lambda squared plus 2 lambda, 1 plus 1 you get 2 equal to 0. So lambda equal to minus 1 plus minus I. So this one you can get it from calculator. So for lambda equal to minus 1 plus I, okay, maybe, so I get minus 1 minus negative 1 plus I. Negative 1, 1 and negative 1 minus negative 1 plus I equal to 0. So this one, I have this one, negative 1 plus 1, you cancel out, so you get I, you get negative I, negative ix, okay, negative ix multiply negative I multiplied with x plus with y equal to 0. And the second row is negative x, this one plus this one, you get cancel out, so you get negative I, so negative yi equal to 0. Then we assume that the x is equal to s, so negative is plus y equal to 0, then y equal to is. So the eigenvector equal to 1 and is. Then we find for the lambda equal to negative 1, negative I. So negative 1 minus with minus 1 minus I. Okay, and negative 1 minus negative 1 minus I. Okay, x, y again equal to 0 and 0. So negative 1 plus 1 cancel out, so you get positive. This one you get positive I plus y. Positive x plus y equals 0. And then the second row is negative x plus yi. This one, negative 1 plus 1 cancel out, so you have the positive y. So yi equal to 0. And then assume the x is equal to s. So si plus y equal to 0, y equal to negative is. So the eigenvector is 1 negative is. Next is to find the whether linearly independent or not. We have I negative I. Oops, that is a positive. And then I negative I. 1 negative I. So negative I minus with negative I. So you get negative 2i, which is not equal to 0. And this is linearly independent. So when linearly independent, it's easy to get the general solution. So based on the formula, we get the general solution of yx equal to c1 eigenvector. Okay, you get 1 and I for the eigenvector. 1 negative I, the imaginary part, you get exponent negative 1 plus I. And then C2, 1 and negative I, you have the eigenvalue of minus 1 minus I lambda. So this one is the eigenvector is the conjugate for the first one. So that's all for the homogeneous system of first order linear differential equation. I hope you can understand and like my video. Thank you very much. Thank you for watching.